Halo, Gina.
Selamat siang, Pak.
Saya close dulu ya, belum sholat.
Iya, Pak. Baik. Siap.
Siang, Prof Jo. Nggak dengar suaranya, Prof Jo. Mute ya? Prof Jo lagi mute ya? Masih mute itu, Prof.
Oh, baru nyampe di rumah.
Baru
Tadi
sampai ya?
Pak di kampus sebentar dengan Pak Rektor kan. Ini baru mandi lagi, baru ini. Rame ya Pak ya?
Iya, mudah-mudahan rame kita nih. Ya, Gina ya.
Mantap
Promosi
nih,
Gina
Gina.
promotornya ini deh.
Enggak, Pak.
Kita
Kita mulai
1.30 kan, Gina ya?
Ya, iya, 1.30.
1.30 kan?
Pak Aswan. Ya,
Ya,
1.30.
sekarang masih jam berapa?
Nanti
1.11 ya?
sekarang masih 1.12, Pak.
Masih 1.12 kan, ya? Masih ada waktu ya.
1.30 nanti juga akan dikabarin ke Ibu Dekan.
Ya, ya. Prof Jo, saya ini dulu ya, sebentar ya. Ada yang mau saya kerjakan sedikit ya. Gina sudah hubungi siapa? Si apa? Felicia?
Sudah, Pak. Ini dia udah jadi co-hostnya juga.
Ya.
Dia udah
Sudah
bantu
tahu ya
saya juga.
tugasnya ya?
Iya, sudah.
Oh iya, oke.
Oke, siap, Pak.
Saya sebentar ya, off dulu ya. Ada yang mau saya kerjakan
Iya, Pak.
sedikit.
Oke, siap, Pak. Selamat siang, Kak Uun.
Siang, Gin. Mulai jam berapa ya, Gi?
15 menit lagi, Kak.
Oke.
Ya.
Prof Badorul sudah ini ya, Gina?
Belum ada, Prof. Belum ada, Pak.
Belum
Saya
join.
sudah kabarin. Saya sudah kabarin lagi barusan, kira-kira 2 menit yang lalu ke WhatsApp beliau.
Ines.
Oke. Terus ya, Kak. Ya.
Bu Dekan sudah hadir, Gina.
Belum, Pak. Soalnya Bu Dekan masih ada meeting juga. Nanti kira-kira langsung jam 13.30, kira-kira mungkin 2 menit setelah 13.30, nanti akan saya hubungi beliau juga.
Iya.
Nanti langsung beliau juga akan join, Pak. Jadi juga sudah saya delegasikan ke Felicia juga supaya melihat itu Prof Badorul sama Ibu Dekan sama Pak Perwira supaya langsung di-admit masuk.
Suara Gina kayaknya kurang keras lah.
Oh iya, Pak. Sebentar.
Iya.
Sebentar ya, Pak.
Prof Jo masih mute itu, Prof Jo.
Ya, nanti Pak Perwira bisa ngomong 2 menit ya, Gin. Nah,
Ya,
nanti,
baik, Prof.
ya biar perkenalkan diri kan.
Ya, terakhir.
Ya.
Ya, terakhir ya, Prof Jo ya.
Ya,
Ya.
tadi juga sudah dibilangin sama Pak Perwira juga sih, udah konfirmasi kalau beliau berkenan nanti dan ada waktu nanti beliau akan masuk untuk closing juga. Gitu, Pak Aswin dan Prof.
Ya. Apa bedanya moderator dengan host, Gina?
Kalau host itu yang ini Prof, yang mengadmit semuanya.
Gitu aja ya.
Kontrolnya Prof Jo, fakultas.
Yalah, oke.
Ada intro lah, penyambung dari Bu Dekan ke
Iya.
ada intro dari fakultas.
Harusnya tadi Pak Aswin ikut presentasi 1 ya kan?
Saya penelitian internasional, Prof Jo.
Biar yang muda-muda muncul ya.
Kita biarkan dulu Prof yang dari luar kan.
Ya.
Teringatnya background-nya udah dibagi semua ya.
Prof Badorul juga sudah.
Di komputer saya nggak bisa Pak Aswin. Jadi
Oh, nggak bisa ya, Prof J? Oh iya, nggak apa-apa lah.
ya nanti gambarnya nggak terang
Iya,
ya.
iya. Nah, sama laptop saya yang satu lagi juga gitu.
Ya.
Kalau pakai background dia blur dia.
Ya.
Ganggu inilah performan video kita.
Ya.
Uun ada nih Uun.
Iya Pak. Iya Pak.
Pak Medis sudah masuk Pak Medis.
Udah ya. Saya nggak. Ini karena banyak tuh nggak nampak ya page-nya ya, Gina ya.
Harusnya sih kelihatan Pak di
Oh ada.
Iya Pak.
Tadi nggak nampak. Saya ini udah nampak.
Ya?
Ya ada. Berapa page? Oh cuma 2 nampak saya di sini.
Oh sudah masuk Pak Prof Badorul.
Udah.
Lagi joining. Ya sebentar saya. Assalamualaikum. Good afternoon, Prof Badorul.
Yeah. Waalaikumsalam. Good
Okay,
afternoon.
how are you?
Fine.
Okay, thank you for being here today, and we're going to start the program shortly.
All right. Okay.
Okay, thank you.
Assalamualaikum.
Salam, Prof. Yeah, Dr. Aswin.
Ya.
How are you? Yeah.
Fine.
How are you Prof Badorul?
Yes, fine. Prof. Johannes,
Ya.
apa kabar? Sehat?
Sehat Prof.
Okay.
How about Malaysia today, Prof?
That's fine. But until now, there is no student in the campus. So the students still at home. And we are going, basically the lecture will be on online. So we have to deliver lecture through WebEx and Microsoft Teams. So most of the time we are delivering our lectures online.
Okay.
What about in USU? Is it the same thing?
Yeah, the same Pak. Lockdown maybe until next year.
Oh, I see.
Yeah.
Well, we are now in our campus. There is no student. Unfortunately, yeah. But then they allow it. Some of the students, those who are here, then they allow them to conduct any experimental work in the lab. But those who are here, okay? But then they have to go for the quarantine for 14 days, and then the university will let them come to the lab and do the experimental work. But basically, the whole campus just like silence, nobody around.
Okay.
All right.
Pak Perwira.
Ya, assalamualaikum Prof Badorul. Ya, Prof Johannes.
Waalaikumsalam. Yes, ya. Prof. Ya. Apa kabar?
Alhamdulillah. Nampak tambah muda Pak Prof Badorul. Muda 10 tahun.
Muda 10 tahun ya. Tapi rambut makin lama makin kurang.
Lupa aja.
Oke.
Kayak ibu asuh ya.
Okay, I think we can start the program now.
Sure.
Okay.
Can I mute first?
Oh yes, of course.
Mute.
Yeah.
Bu Dekan udah hadir, Gina.
Ini lagi sudah saya WhatsApp. Pak.
Oh iya.
Apa kita mau nunggu juga sebentar? Kira-kira?
Iya, nunggu sebentar ya, nunggu Bu Dekan.
Baik, nggak apa-apa. Saya sudah barusan WhatsApp beliau, karena beliau juga sedang ada Zoom juga.
Ya, tunggu sebentar, mungkin.
Ya, mungkin tadi sekitar 5 menit ya, Pak.
Iya.
ada banyak student ya, yang hadir dalam Zoom ini. Hampir 300, Pak Badrul.
Ini campur-campur nih, Pak Perwira.
Partisipannya 200.
Ada yang daripada S1, S2, dan S3 ya?
Ya.
Ada yang kita dari luar juga.
Ya. Juga ada yang bergabung di YouTube.
Nur Samsi juga ada, cuman dia belum tahu bagaimana mau pergi Malaysia lagi karena kena
hadir Pak.
Kena apa ya 14 hari di sana oleh sedikit.
Dan kami pun tidak, dosen-dosen pun tidak dibenarkan untuk keluar sekarang ini. Tidak dibenarkan dan international flight memang terdapat restriction. Saya kurang arif tentang Zoom ini. Kalau share nanti saya akan share daripada PowerPoint saya atau bagaimana?
Nanti saya bantu aja Prof Badorul.
Tapi sharing itu
bisa saya buat jadi co-host, jadi Prof Badorul langsung bisa.
Kalau saya sharing daripada komputer saya boleh?
Bisa.
Oke.
Saya juga sudah buat jadi co-host, jadi bisa share screen langsung, Prof Badorul.
Okay.
Yeah, so you can directly share your screen.
All right.
Okay.
Bu Dekan udah masuk itu.
Ibu Dekan udah masuk.
Assalamualaikum, Prof Badorul.
Waalaikumsalam Bu. Apa kabar? Sehat?
Sehat, alhamdulillah. Sudah
Alhamdulillah.
1 tahun kita tidak ketemu.
Iya. Oke. Pelajar tidak ada di kampus?
Tidak ada.
Oh ya. Sama di sini, sama saja. Di sini pun seperti kampus seperti dilanggar Garuda.
Ya.
Okay.
Okay, so I guess we can start the meeting, the webinar now.
Ya, okay.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Warm welcome with it to our excellencies, keynote speaker, distinguished guests, and participants to the first world-class visiting professor 2020 on general lecture High Performance Concrete by Professor Badorul Hisham bin Abu Bakar from Universitas Malaysia. Thank you to all our participants who are also joining us on live streaming on YouTube from Fakultas Teknik Universitas Sumatera Utara channel. So in this lovely afternoon, it is an honor to me to inform you that we have our keynote speaker, Professor Badorul Hisham bin Abu Bakar from Universitas Malaysia, our Dean of Engineering Faculty, Universitas Sumatera Utara, Insinyur Seri Maulina MSc PhD, our Vice Dean of Engineering Faculty of Universitas Sumatera Utara, Professor Dr. Ing Johannes Tarigan, Head of our Postgraduate Program, Department of Civil Engineering of Universitas Sumatera Utara, Dr. Insinyur Ahmad Perwira Mulia Tarigan MSc, and also the Secretary of our Postgraduate Program, Department of Civil Engineering of Universitas Sumatera Utara, Dr. Insinyur Muhammad Aswin, ST, MT, and also our participants, both lecturers and students, including from Universitas Muhammadiyah Sumatera Utara, Universitas Negeri Medan, Institut Teknologi Sumatera, Institut Teknologi 10 November, Universitas Gajah Mada, Universitas Brawijaya, Politeknik Negeri Jakarta, Universitas Hasanuddin, Politeknik Negeri Kupang, Universitas Tadulako, Universitas Khairun, Institute Technology PLN, another university that we cannot mention one by one. We really appreciate your presence for being here in this today's webinar. We also would like to greet PT Waskita Karya, the representatives of PT Waskita Karya, and also the PT Pembangunan Perumahan and Ministry of Public Works and Housing, and also the Department of Civil Engineering lecturers, and not to forget our incredible undergrads, fresh grads, postgrads, both doctoral and master students, and our alumni, and all the invitees that I cannot mention one by one. We really appreciate that you have joined us today in this webinar. My name is Gina Cynthia Ravitazibwan, and I will be your moderator for today's webinar. So first of all, let us praise and thank the presence of God for the abundance of His grace that all of us can still gather today. And this webinar is organized by the Postgraduate Program Department of Civil Engineering of Universitas Sumatera Utara. So ladies and gentlemen, as we all know, there is a slight change in terms of the way the seminar has been held due to the emergence of the COVID-19 pandemic. And now we are already being accustomed to be in a Zoom webinar. So in relation to the reason why this webinar is held, the goal is to implement the world-class university program created by the Universitas Sumatera Utara by bringing in visiting professors from abroad. So in the long term, there is an expectation that these visiting professors or visiting scholars will often give seminars frequently and regularly. So, and we also would like to introduce Professor Badorul Hisham bin Abu Bakar to our lecturers in Civil Engineering Department of Engineering Faculty, Universitas Sumatera Utara. So they, so in the long term, they can make a lot of international research collaborations, which is also one of the programs of the Directorate General of Higher Education, Indonesian Ministry of Education and Culture. So for your information, Universitas Sumatera Utara and University Science Malaysia also has made an international MOU. And we have done several cooperations and collaborations, which includes field trips of undergrads, of our undergrads and postgrads to University Science Malaysia. Also international conference where Professor Badorul acted as the keynote speaker. And also Universitas Sumatera also has invited professor in University Science Malaysia for acting as a both supervisor and external examiners for the postgraduate students of Department of Civil Engineering of Universitas Sumatera Utara. So therefore, this webinar is expected to not only enhance our knowledge in the advance of concrete technology and its applications, but also is expected to create more room of opportunities for international research collaborations between Universitas Sumatera Utara and University Science Malaysia. So ladies and gentlemen, before we move to the next agenda, let me read today's rundown. That will begin with the opening remarks from Vice Dean of Engineering Faculty, Professor Dr. Johannes Tarigan, as the host of today's webinar. And then after that, we will hear the opening remarks from the Dean of Engineering Faculty, Insinyur Seri Maulina, MSc PhD. And then after that, we will have our main agenda, which is the general lecture on high performance concrete by Professor Dr. Badorul Hisham bin Abu Bakar from University Science Malaysia. And then followed by the Q&A sessions. And then after that, we will have our closing sessions. So, Excellencies, keynote speaker, distinguished guests and participants, ladies and gentlemen, we are now going to listen to the opening remarks by the Vice Dean of Engineering Faculty of Universitas Sumatera Utara, Professor Dr. Johannes Tarigan. So, ladies and gentlemen, please welcome Professor Dr. Johannes Tarigan. Thank you.
Thank you, Dr. Gina. Good afternoon, ladies and gentlemen. I would like to thank all of webinar participants today. Our Dean, Ms. Seri Maulina, PhD, Ahmad Perwira, PhD, Chairman of Postgraduate Program of Civil Engineering Department of Universitas Sumatera Utara, Aswin, PhD, Medis Surbakti, PhD, Dr. Ridwan Anas, and all of my colleagues and all participants today, especially for Mr. Professor Badorul Hisham Abu Bakar from USA, Malaysia. Thank you very much for giving presentation today. Currently, more than 400 have been registered in this webinar. This webinar is one of our university's program. We can call it World-Class Visit Professor Program. This World-Class Visit Professor Program consists of general lecture for undergraduate students, lecture for postgraduate students, joint research, and joint publication. In the vision and mission of our university, we have milestones that we have to start with internationalization programs and also international accreditation. Today, we have a program general lecture. The topic of general lecture today is about high performance concrete. Before we start today, I hope our Dean, Mrs. Seri Maulina, PhD, can give a speech for our participants. I hope the topic of great interest of all participants, and please enjoy this webinar. Thank you very much.
Okay, thank you to Professor Dr. Injonas Hargan for the opening remarks. So we continue with the opening remarks and also as the symbol of the official opening of this webinar today, delivered by the Dean of Engineering Faculty of Universitas Sumatera Utara. So ladies and gentlemen, please welcome Insinyur Seri Maulina, MSc, PhD. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Honorable Prof. Dr. Untitled, Rector of Universitas Sumatera Utara. Honorable Speaker, Professor Dr. Badorul, Honorable Vice Dean, Professor Dr. of Master and PhD Program, Civil Engineering Department, Faculty of Engineering, Honorable lecturers, committee members, students, distinguished guests, ladies and gentlemen. First, allow me to start by wishing you and your family my personal best, especially for our health and safety in this difficult and challenging time. We are still a long way to go before after goes to normal, and I hope that everyone can maintain energy in this marathon until we arrive at the finish time. As the Dean of Faculty of Engineering, I'm delighted to virtually welcome you to the world-class visiting professor held by Master and PhD program, Civil Engineering Department, Faculty of Engineering. The aim of the world-class university of the Ministry of Cultural Education program is to encourage universities in Indonesia to improve their academic reputation international level. The measure parameter that is used as a reference in the quarterly Simon's QS World University Ranking. The target to be achieved at this time is to carry 14 Indonesian universities in the 500 QS World Ranking. Alhamdulillah, currently USU is the first cluster, so that it has to be opportunity to participate in the QS World program by Ministry of Cultural Education. World-class visiting professor is one of the program of the Ministry of Cultural Education in World University Ranking with 4 activities, namely public lecturers, joint research, which are expected to produce international patents, joint publication, and speakers. Through this world-class visiting professor program, USU lecturers and researchers have the opportunity to collaborate with world-class professors from various well-known foreign universities. This program is intended so that lecturers or researchers can interact with well-known and excellent professors so that they can improve academic life and competencies. I would like to express my sincere appreciation and thanks to Professor Badorul for sharing knowledge, also to all participants, especially the members of civil engineering lecturers and students, and all committees members for the successful event. Moreover, my sincere gratitude to Rectorate of University Sumatera Utara, Prof. Dr. Untung, for the great support this event. I hope you all have a great time during this webinar, make a lot of new friends and colleagues, and create good academic network. Thank you and good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the opening remarks from the Dean of Engineering Faculty of Universitas Sumatera Utara, Engineer Seri Maulina, MSc PhD. So before we move to our main agenda, we will have a short photo sessions where I will take the screenshot of the Dean, Vice Dean, and the Head and Secretary of Postgraduate Program of the Department of Civil Engineering, Universitas Sumatera Utara. So I hope that you are all ready. So on the count of 3, 2, 1. Right. Thank you very much. Okay. Right. So right now we will have our main agenda. First of all, I would like to, on behalf of the organizing committee, I would like to say thank you to Professor Badorul Hisham bin Abu Bakar from University of Malaysia for agreeing to be our keynote speaker for today's webinar. And we appreciate that you take your time to join us this afternoon and share your knowledge with us. And however, before Professor Badorul Hisham bin Abu Bakar
I think we lost Gina's voice.
Yes, we lost the voice. Yeah, okay.
Is Gina still here?
Halo, Gina.
Yes, sorry for the technical difficulties. So I will continue again. Right. So he has an area of expertise in masonry structures, timber structures, concrete structures, and structural analysis. And he's also currently a chairman of technical committee for clay bricks and blocks from 2004 until today. And he is also the standard writing committee from 2020 until today. So from the academic qualification, Professor Dr. Badorul Hisham bin Abu Bakar is also receiving his diploma kejuruteraan awam or civil engineering from University Teknologi Malaysia in 1990, and then he continued to receive his sarjana muda kejuruteraan awam or civil engineering from University Sains Malaysia in 1993, and also after that he continued his master degree from Leeds University in 1994 and received a Master of Science, and then finally he received his doctoral degree, Doctor of Philosophy from the University of Leeds, United Kingdom. So he currently has a professional membership from 2009 until today. He is the Board of Engineering Malaysia, and then from 2007 he is also a Mercy Council member, and then from 2011 until today he is also the chairman for Technical Committee of Timber Structures. And from 2017 until today, he is also the member of Engineer Malaysia. So Professor Badorul Hisham bin Abu Bakar has more than 40 publications, but I would just like to latest publications of him, where in 2020, his publications in which the title is Experimental Investigations on Mechanical Properties of Plain and Rubberized Concretes with Steel Polypropylene Hybrid Fiber is published in Constructions and Building Materials. He also has supervised and examined more than 23 supervisions, and then the latest one of his students who has graduated, where he is the main supervisor, is the influence of crumb, rubber aggregate, and hybrid fiber on toughness and impact load of concrete. So as an external examiner, he has supervised 20 and then also examined 23 students. And as your information, Professor Badorul Hisham bin Abu Bakar is also the external examiner of our own Secretary of Postgraduate Program, Department of Civil Engineering of Universitas Sumatera Utara, Dr. Engineer Muhammad Aswin STMT, who received his PhD in Civil Engineering in 2018, and the title of his thesis is The Performance of Reinforced Concrete and Reinforced Engineer Cementitious Composites, Shaft and Beams. And he is also Professor Badorul Hisham bin Abu Bakar, also the current supervisor of one of my colleagues, Engineer Nur Shamsi STMT. And for the awards and recognition, Professor Badorul Hisham bin Abu Bakar received lots of awards and recognitions, but I would like to highlight that he has received silver medal for the utilizations of ceramic waste as concrete pavement, and also he received Anugerah International Conference and Expositions on Invention of Institutions of Higher Learning Pencipta 2013, and he received bronze medal for retrofit ultra high performance concrete repair material. And he also received Anugerah Sanjung 2014 from the Penerbitan Journal, and Anugerah Tokoh Standard Kebangsaan 2017 from Standard Malaysia. For the training and attachment and visiting, he was the visiting professor in Chungnam University in Daejeon, South Korea in December 2012. He was also the visiting professor in Salahuddin University in Iraq in 2009, 2013, and 2015, and he has visited us last year in University Sumatera Utara, and the latest one where he acts as this visiting professor is in Turkey at Osman Ghazi University in February 2020, before the COVID-19 pandemic hit the world. So I guess this is the kind of introductions that I would like to give for Professor Badorul Hisham bin Abu Bakar. So without any further ado, Professor Badorul Hisham bin Abu Bakar, are you there?
Yes.
Yeah.
Yes. Right. So can I share my presentation, or you will share my presentation?
I can share your presentation.
All right.
Okay.
So when you share that presentation, that means you will control my my PowerPoint, isn't it?
Yeah. But if you want to control your own PowerPoint, I already give the as a co-host for you, so you just need to share your screen.
Okay.
And then after
That, let me control the PowerPoint.
Yeah. No
Right.
worries, Prof.
Thank you very much, Dr. Gina, for a very lengthy introduction. And I already asked her not to introduce too long. Okay, just summarize it. Anyway, thank you very much to the Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera. Good evening, good afternoon to everyone. First, I would like to thank the organizing committee from the world-class programs, with the international cooperation on science, engineering, and technology, Universitas Sumatera Utara. Credit to Prof. Johannes Tarigan, and also the Dean of Teknik Sipil, Engineer Sri Maulina, and all my colleagues in USU, Universitas Sumatera Utara, Professor Rosianto, Dr. Daniel, Dr. Medis, Dr. Ahmad Perwira, Dr. Rudy, Dr. Aswin, and Dr. Ridwan, and also Nur Samsi as well. I think he's around. Okay, let me share my little bits of my knowledge on the performance of high concrete, high strength or high performance concrete. Let me share my PPT, please. Yes. All right. Can you see it?
Yes, Professor Badorul.
All right. Thank you very much. Right. Again, this is part of the collaboration program under the MOU between USM and also Universitas Sumatera Utara. Apart from, as mentioned by Ibu Dekan just now, not only on research but also on joint supervision and also joint seminar and so on. So we had a seminar previously with Prof. Johannes Tarigan and also from Jakarta, Professor Haryanto. Yes. From Predita University. Okay, so that is part of our program as well in our collaboration between two universities. The hope, not only this platform, but we're going to have another platform to work together, to have a seminar together and so on. So my presentation today is on the high performance concrete. Right. So everybody knows about concrete. Concrete is a versatile material for the construction. And as all we know that the normal we used to have a normal concrete. Okay. But this high performance concrete is I would say is a special concrete, not the same with the normal concrete, with special application basically, right? So nowadays we have a lot of problem in concrete, especially for normal concretes. So why we need high performance concrete basically? Is that enough? Is the normal concrete is not enough? Is the normal concrete insufficient? Is the normal concrete not work very well for so far? Because we have been using concrete for so many years, since early 90s and so on. But until now, we are still developing concrete to get the best type of concrete, to get a good type of concrete. Now, we need to have high performance concrete. Why? This is one of the problems, corrosion. Right? Corrosion is one of the problems that we need to have high performance concrete. As we know, strength is one of the overriding factor. Overriding factor means the most important parameter to be used to judge the concrete, to judge the performance, to judge the not only performance but to judge the quality of the concrete. But nowadays, strength is no more becoming the overriding factor. There are other factors which need to be looked into for the performance of the concrete in the long term. This is one of the problems. We can see the corrosion of reinforcement in the concrete. And this is also concrete corrosion. Apart from corrosion, we have a concrete spalling due to the aggressive environment, for example, under the attack of chemical attack, for example, under the impact load, for example, the failure, and next is, you see, creeps and shrinkage. One of the problems that we need to tackle in the construction industry when you are using concrete. So creep is basically a time-dependent movement of concrete, right, under load. Another thing is shrinkage. Shrinkage is also a time-dependent movement, which eventually the concrete will cracks because of the shrinkage and also because of the creeps. So you can see here, there is a deflection due to creeps, okay, time-dependent movement of the concrete. So we don't want that to happen as well. And of course, when you talk about the high performance concrete, what you need? You need the concrete with the high workability, easily to flow when you pump it, easy to compact it. That's why the previous talk, in the previous lecture, if some of you still remember, we are talking about the self-compacting concrete. So the high performance concrete is basically also will try to accommodate the self-compacting concrete as well. Then that's why we need to tackle all these problems. The problems because of the insufficiency in certain area of the concrete to tackle it, right? So the high performance concrete is not only give you the better strength, it's not only give you a good strength with the high strength concrete, but also will tackle the issue of durability. All the previous slide that I have given to you mostly are the issues of durability of concrete. Concrete spalling, concrete cracking of concrete, corrosion of the reinforcement, and shrinkage and creeps, which eventually, even though it's a time dependent, but eventually it will damage the concrete in the future. Therefore, that this is what we call it degradation of concrete. Okay, degradation of concrete due to the corrosion of reinforcement and also causes by the mechanical, physical, structural, chemical, biological, and also the corrosion as well. So all these, by using the high performance concrete, all these can be solved, and also the members of concrete members can serve in the long term. Okay. Next. What are the difference between the high strength concrete and the high performance concrete? There are two things. Okay. You're always talking about the high strength because, as I said earlier, the high strength concrete, you need a very strong concrete. Okay. But nevertheless, high strong concrete doesn't mean that it will last long. We need something to ensure that the concrete will perform better in the long term. So what is the difference between high strength concrete and high performance concrete? If you look into the definition of this, high strength concrete is defined based on compressive strength, because as I said, compressive strength is the overriding factor. When you order the concrete, you want to have grade 35, grade 40, grade 50, or grade 80, and so on. At a given age, where high performance concrete is defined based on performance criteria, high durability, high strength, and high durability, high workability. Okay, so that is the between high strength concrete and high performance concrete. That is the difference. So that means high strength concrete has a certain values which doesn't have in the high strength concrete. When I speak, there's something echoes. Can you hear me clearly?
Yes, Professor Badorul.
Yeah.
Okay, sorry.
Yeah.
So the high performance concrete is defined as a concrete that meet special combination of performance and uniformity requirements that not always be achieved routinely using conventional constituents and normal mixings, placing and curing practice. So we have to upgrade all these in terms of the constituents, which is the material of the concrete. Setting time could be earlier, and placing, curing practice. also a little bit different if you compare with the normal concrete or conventional concrete. However, high-strength concrete is defined as a concrete that has a concrete strength of 55 megapascal or higher. This is according to ACI. But if you refer to BS, British Code, for example, this value is lower. I mean, British Code can consider 45. 40 is already a high-strength concrete. But if you refer to this code, ACI, they define high-strength concrete 55 and above. But if you refer to Eurocode, they are also different. But the basic idea is, or the basic need is the high strength, not the performance. So the use of high-performance concrete has overcome many problems, as I said earlier, observed in the conventional concrete. For example, in the case of durability. Durability is to ensure the concrete can last in long term. It can serve without any problems. It can serve the, what you call it, it can reduce any concrete damage in the future. And with the low resistance to the chemical attack, if you can improve the microstructure of the concrete, of course, you can lower the risk of chemical attacks and difficulties in repair and retrofitting works. High-strength concrete has been used in construction for many structures to decrease size of member, reduce that load, and decline costs. So we'll discuss on this after this in terms of size of member. For example, high strength for the normal concrete, let's say you need about 500 to 500 columns. With the high performance concrete, you can reduce to 400 or 350. Okay, the size of the column, but you will attain the same strength, even higher strength, if you compare with the high strength concrete. So that is the idea of high performance concrete. Right. Before we go further, we need to look into the characteristic of high performance concrete. What are the characteristics of high performance concrete? Number one is high strength. The strength is high. Okay, the strength can go to 55, can go to 80, can go to 120, and so on, even up to the ultra high performance. That one's different issues. And high early strength. Why we need to high early strength? Why high early strength is because we need to save the time. In conventional, probably we have to go for 7 days, 14 days, and 28 days, even 19 days, for example. With the high performance, you can reduce the early setting time, so they will be able to get high early strength. High elastic modulus is basically a correlation between high strength and high elastic modulus. The higher the strength, the higher the elastic modulus. That's simple. And high abrasion resistance as well. Okay, you know, concrete is a very brittle material, right? If you have any abrasion or any friction between the concrete, the concrete will not easily back off or easily fall off from the structures. High durability and long life in severe environment. This is the problem with the concrete nowadays. Not able to accommodate or not able to protect themselves from the severe environment. What are the severe environments? They are under the sulfate attack, under the other chemical attack, carbonation, chloride attack, and so on. Even, for example, the marine structures. The marine structure, if you don't put something to stop any aggressive environment coming in, they will be discomposed and so on. I mean, there will be corrosion and so on in the future. And low permeability and diffusion. Of course, low permeability reduce the porosity, reduce the ability of water to ingress, for example, and diffusion. Diffusion is something to do with the gas coming into the concrete. So if we can keep it low, improve the microstructure, they will be good for the long-term performance. And resistant to the chemical attack as well. Higher resistance to frost and de-icer scaling damage. This is not happen in Malaysia and also may not be happen in Indonesia. But in some part of Indonesia, some part of Indonesia, I've learned that you have a cold weather, isn't it? Cold weather. So they might have frost and de-icer scaling damage. I'm not sure. But of course, in European countries, they have this kind of problem, freeze and thaw. Toughness and impact resistance, yes. Improve the toughness and impact resistance. Volume stability, ease of placement. When you have a high workability, for example, easy for you to place it, easy for you to pour it. There is no stuck in the pumping in the short plate, for example. Compaction without segregation, right? So as I said earlier, high workability and it can be self-compacted, then it is still under the high performance and inhibition of bacteria and mold growth. But now this issue, a bit of I would say a lot of debate on this issue, because nowadays you have self-healing concrete. In self-healing, you need to have bacteria in the concrete so that it can be self-healed when you have cracks. So that one is different issue. We can talk about it on the self-healing. Right. Next. This is the important part of the high-performance concrete. Selection of the material in the high-performance concrete. The production of high-performance concrete involves in the following important criteria, which is the selections of suitable ingredient for concrete, and also it should be having a desired rheological properties, strength, etc. And we have to determine the relative quantities of the ingredient in order to produce durable concrete, and we have to select a proper material carefully. Proper ingredient to ensure that the concrete will attain high performance concrete. So these are the material. Okay, the Portland cements, blended cement, fly ash slag of silica fume, calcium clay or metakaolins, calcium shell, super polarizer, high range water reducer, hydration control admixture. All these will contribute to the cementing material, will contribute to the durability, a high strength. Of course, these are the admixture, okay, and this mineral admixture which contribute to the high strength, especially the silica fume. And part of it, for example, fly ash can be classified as a cement replacement material. All right. Right now we try to use a POFA, palm oil fuel ash, and also RHA, rust ash, as a cement SEM or cement replacement material. It can be treated to what you call it to achieve high performance concrete. So therefore, this is still under research. But then POFA and RHA is already what you call it good in achieving the high performance concrete. And in fact, in Indonesia also you have a lot of RHA, and in fact you have also other material from Gunung Berapi, for example. Okay, and super polarizer. This is important to maintain the workability, the required workability, so that the concrete can flow easily. This is what we call it flowability. And reduce water cement ratio. In concrete, once you use a lot of fine material, you need a lot of water. But as you all know, using an excess of water is not good for concrete. So we have to reduce this chemical to reduce water cement ratio by introducing super polarizer to maintain the required workability. and also control the setting point, control setting as well of the concrete. Right. And this is another material as well. This is another material as well. Retarder, accelerator, corrosion inhibitor, water reducer, shrinkage reducer, ASR inhibitor. You know, ASR is alkali silica reaction. To avoid any alkali silica reaction, you have to select a proper aggregates, because some aggregate affected by ASR, which is no good to the concrete. At the end of the day, you can see the concrete, something fluid will coming out from the concrete, a whitish fluid, which is not good. So make sure that we have to ensure the aggregate has not any ASR, alkali silica reaction. And polymer latex modifier, this is also for the durability and other material. These are some of the material to be used in the high performance concrete. Right. If you look into this diagram, it's a very simple diagram. Take out the fibers. All right. We don't want to see the fibers. So these are the cement. Okay. Silica fumes, filling powders. It can be GGBS, it can be fly ash and so on, and also aggregates, the fine aggregate, right? So all these are hand in hand. They are together, right? So you can see if there is any voids here, they will be harmful to the concrete. But in this case, they want to increase the tensile strength of the concrete. Later, we can discuss about it. Right. This is again the material, special material for the high performance concrete. You can see here we have gravels, which is aggregates, and you have sand here, right, which is important material in concrete, and you have cement and other material here, metakaolin, fly ash, okay, or other mineral fillers and so on. But you should have the silica fume here. Silica fume, of course, will contribute to the high strength concrete. Okay, and the concrete become very dense. In order to produce high strength concrete, make sure the concrete is dense. Densifications of the concrete through all this material. Right. These are the properties. We end up with these properties. Selected properties of high performance concretes. If you look to ASTM, you can see all these. These are the required properties: high strength, okay, abrasion resistant, low permeability, chloride penetration, high as a guideline for you to achieve if you are referring to the ASTM. Okay, so all these are important properties, and also other properties as well. For example, low diffusion coefficient. So diffusion is referring to the ingress of gas, for example, parameter to look at it, to stop from the ingress of gas. Resistant to the chemical attacks, sulfate attacks, high modulus of elasticity, high resistance to FT damage, high resistance to the de-icer scaling, low shrinkage, and low creep. These are the important properties should have in the high strength, high performance concrete. I was discussing about the high early strength. Why we need to have the high early strength? Because we expect the high performance to have the high early strength. You know, when you are using the cement replacement materials, RHA, or you are using fly ash, for example, in most cases, all this material apart from the cement replacement material, normally they are involved in the second phase of hydration. They are involved in the second phase of hydration. That means the early strength will be delayed. Early strength might be delayed. But you have to modify it with other material, retarder or whatever, reducer or whatever, okay, so that you can achieve the high early strength. So the high early strength, according to the ASTM or H2, between 3 to 12 hours, you can achieve, or between 1 to 3 days, you can achieve 20 to 28 megapascal. At this time, at this strength, you can strip off your formwork. Okay, and high early strength, this is in compression. High early strength in flexural strength, between 3 to 12 hours, you can achieve between 2 to 4 megapascal. In conventional concrete, this will be achieved in 28 days or 14 to 28 days, which is a longer period of time. Then, high early strength, it can be achieved with the high amount of cement content. Okay, in this case, probably from 400 is normal, 350 is normal for the conventional. But for the high cement content, you need to have between 400 to 600 or between 400 to 750 and so on. And lower water cement ratio with 0.2 to 0.4, but this has to be modified with the super plasticizer to maintain the required workability, and higher freshly mixed concrete temperature and higher curing temperature. Right. With the high performance concretes, normally we treat them, we cure it under the high elevated temperature. Okay, but there are so many methods of curing nowadays. Even one of my students doing research on how to come up with the curing. So she has to put it into the mix with the hot water, for example. That is one of it, right? There are so many methods. You can spray it, you can do it something else, you can put chemical and so on to promote the hydration of the cement and so on. Right, and it can be also achieved using the chemical admixture. Okay, the chemical admixture. There are so a lot of chemical admixture. You can use retarder, air entraining agent, and so on. Okay, chemical admixture and silica fumes. That is the mineral admixture basically. And also steam or autoclave curings, as I mentioned earlier, under the elevated temperature. Isolation to retain heat of hydrations and special rapid hardening cement. So these can be achieved to attain high early strength concrete for the high performance concrete. Right. Strength data from the fast track, you can see the increase of the strength from hours to 28 days. Right. So these are the things, but here is only to 40 days, 40.7. It can increase more. It can be up to 19 days for the high performance concrete as well. So the strength developed of high early strength concretes, you can see the fracture strength and also the times and hours with the 390, which is low, quite low amount of cement. Okay. And with the very high amount of cement. So there is a difference of the early strength of concrete in the flexural strength as well as in composite strength. Okay, so the blanket insulation, as I mentioned earlier, okay, standard cure or insulating blanket. This is different type of curing methods. You can have insulating blanket to cure to protect the concrete, especially at the early age, so that there is no influence of ambient temperature, there is no influence of relative humidity, for example. Okay, in Malaysia and Indonesia, the relative humidity is not very crucial. But if you go to the European countries, for example, in some countries, their relative humidity is very low. So the relative humidity very low, so it will sorry. It will affect the hydration process. Let's say in some countries, the relative humidity 45%, and the temperature can go to 50%, 50 Celsius. So it's very high temperature, very low relative humidity. Of course, it will affect the hydration process. So you can blanket, you can install it, insulating the concrete members. Okay, cement. Cement is physical and chemical characteristic of cement. It's play a vital role in developing strength and controlling rheology of fresh concrete. Okay, fineness, basically the fineness of the concrete affects the water requirement for consistency, for example. When we look for the cement to be used in the high performance concrete, one should choose cement containing a little C3A as possible, because the lower amount of C3A, the easier to control the rheology, or lesser problem of cement superpressure compatibility. So finally, from the strength point of view, okay, this cement should be finally ground and contain a fair amount of C3S. Okay, so you have to keep C3A lower and also a fair amount of C3S to promote the hydration process. And basically cement, we have to test, as you know, based on the mortar cube test, based on the concrete cube test. Here we are using 100 cube test, and also the days of testing, 3 days, 7 days, 14 days, and so on, and also the amount of cement play the vital role, the main role in developing the strength of the concrete. Look at the aggregates. Aggregates, there are two. One is fine aggregate, the other one is coarse aggregate, of course. And aggregates in concrete, 70% of concrete contain aggregates. Meaning that basically you should have a strong aggregates in order to achieve a strong or high strength concrete. That's important, because the cement, fly ash, all those kind are the binders. But the core, the important part is aggregate. As I said, we have two types of aggregate. One is coarse aggregate, the other one is fine aggregate. The coarse aggregates is the strongest and should be less porous component of concrete. If you have porous aggregate, it's no good. Okay, there will be a lot of what you call it, absorptions, and also the TSZ, the transition zones, will be weaker. If you have if you don't have a very, if you have what you call it, a weak aggregate. So in this case, for the high performance concrete, normally the size of aggregate between 9.5 to 12.5 millimeter or up to 15 millimeter. That is the most. Okay, that is the maximum required. Even when we prepare the ultra high performance concrete, we are using 14 millimeter. You can ask Nur Samsi. I think she knows about the ultra high performance concrete. And combining the single size of required grading allow for closer control and reduce variability in concrete. For 70 megapascal and above and greater, the fine modulus of the sand should be finest modulus of the sand should be between 2.6 to 3.2. Here in Malaysia, we have about 2.65. Okay, so lower may give lower strength and sticky mixes because you need a lot of water to wetting all these aggregates. This is supplementary cement material. Okay, supplementary cement material, or we call it mineral admixture. for the high strength concrete. You have fly ash, silica fumes, or slag are often mandatory, and the dosage between 5 to 20% or higher by mass or cementing material, and in some specification, maximum of silica fume should not more than 10%. Right. According to the research, fly ash, RHA, POFA, and other SCM, supplementary cementitious material, normally less than 20%. Less than 20%. Okay, that is the most usable in the market. I don't know, because if you put more, they'll need more water and more reducer, which is not good to the concrete. So they must keep it at a certain limitation for the concrete. And these are the material which can be used in the high performance concrete. Okay. And these are the major difference if you compare with the high performance concrete and the conventional concrete. Okay, with all this material. Okay, and by adding this material, okay, for example, like fly ash and silica fume, as a pozzolanic material as well as a fine filler, okay, it will improve the microstructure of the hardened cement matrix because it will become denser and stronger. Okay, improvement of the microstructure of the concrete is very important. Okay, for example, the use of silica fumes fills the space between cement particle and between aggregate and cement particle, and that will improve the intershell transition zone, as I mentioned earlier, between the cement paste and also the aggregate. Right. Then admixture, as I mentioned earlier, this is what we call it chemical admixture. Previously, you can call it a mineral admixture, but here a mineral admixture plus supplementary cementing material. But this is what we call it chemical admixture. The chemical admixture is essential for this ingredient in the concrete mix because it will increase the efficiency of the concrete paste by improving the workability of the mix and thereby resulting considerable decrease of water requirement. As I said, you need water in concrete, but not too much. If you have a lot of water, it will create a lot of voids. Once you create a lot of voids, there will be a porosity, there will be more permeability and so on, which is not good. Right. So by introducing this admixture, use of water reducer, for example, retarder, or the superposizer, is mandatory in the high strength concrete. High water reducer. Okay. Air entraining admixture, not necessarily or desirable in protecting high strength concrete. Okay, sometimes air is mandatory because air will allow the concrete move easily because you provide something repellence in the concrete between the material, between the ingredient. Okay, so but then of course there is a limitation in using air entrainment. So because the air entrainment or air entraining agent artificially introduce the air bubbles, which increase the workability of the mix and enhance the resistance to deterioration due to the freezing and also thaw action, which not happen in Malaysia, might be in Indonesia as well. Right. Let's look into mixing. Mixings, central plant or truck mixer. Truck mixings reduce loads to 90% of rated capacity, and pre-qualifications of concrete supplies is recommended. Of course, mixings will be made in the factory, and of course you will automatically mix and it will become a ready mix. Okay, but then it must be properly designed accordingly. That means what is the need of the contractors, what is the needs of the, then they will supply the correct strength grade, the correct type of concrete and so on. Right. Placing, consolidations and curing. Of course, delay in delivering and placing must be eliminated because you must make sure the setting time, okay? The distance between the factory and the project. Sometimes they make it on site, which is better. Okay, if you have a huge project, then they will manufacture the concrete on site. That's good. There is no issue on delivery and placing as well. Okay, you know, in placing the concrete, you must have certain height to pour the concrete. Otherwise, it becomes segregated, bleeding, and so on. That has to be avoided. And also curing. Okay, and consolidation, very important to achieve strength. As I said, compactions, that is considered as consolidation as well. So by using self-compacting concrete, introducing the self-compacting concrete in this type of concrete, you will not able to have, I mean, you don't have to use vibrators for you to compact the concrete. Of course, the concrete can be compacted by itself. Slump, this is the slump, generally between 180 to 220. That is the to ensure you will get the required workability. A little, if any, bleeding, fogs or evaporation retarders have to be applied immediately after strike off to minimize plastic shrinkage and crusting. So this is again, after you pour the concretes, normally if you don't treat them properly or cover it, they will have a plastic shrinkage next day or after 3 days. So plastic shrinkage, you can see the cracks on the surface of the concrete. Okay, the cracks on the surface of concrete, which is not good for your concrete. Okay, and also curing, which is also very important in curings because you need to cure it properly. Otherwise, as I said earlier, insulating, or you have to have spray on the concrete. You can have a different type of curing under the enclave curing or elevated under the elevated temperature, for example. Then there are so many methods in curing, but the curing, moist curing is very, or water ponding, for example, is very good for curing to save the cost. Right. These are the mixed proportions of the properties of the high strength concrete, basically with the high performance concrete as well. Okay, those are the cement, silica fume, and fly ash. This is what we call it ternary mixed proportion. This is binary mixed proportion. So you can choose between two. If you need to have fly ash, you need to have silica fume, you must go, or cement with only silica fume. These are the results of the properties of high strength concrete, but also can be considered as high performance concrete as well, right? And this is another one, another mix with the very high cement content, right? Very high cement content, and also silica fume and fly ash. The one with the fly ash, the other one without fly ash, you will get all this. Of course, this will get you more in terms of strength if you compare with the previous mixture. Right. High durability. This is the important parameters for the high performance concretes. Okay. In those days, we only refer to the strength because as usual, as an engineer, when you order the concrete, what is the strength? What is the grade of concrete you want? Isn't it? Not the durability. You don't think about the durability. But today, since we have seen a lot of damages due to the durability issues, then we have to focus not only on the strength, but also to have high durability, the high performance. Durability issues that the high performance concrete can address, as I said, number one, abrasion resistant, blast resistant, permeability, carbonation, freeze and thaw resistant, chemical attacks, alkali silica reactivity, and also corrosion rate of rebar. This is basically, you know, rebar, the environments, rebar in the concrete, they should have in the high alkali situation, high alkali condition. If it is acidic, then the corrosion will take place. So how to maintain the alkalinity of the concretes, especially around the bar? That is important issue to discuss. Applications of high performance concrete. Of course, when you talk about the application of high performance concrete has the properties of high strength, compressive strength, have the property of workability, have the properties of durability, and also density. So type of concrete here, if you look here, you are basically should have high strength, should have self-compacting, should have a high strength concrete, chemical, mechanical, should have high strength concrete, high density concrete with low permeability. So this area of applications is not fixed here, but you can go for the high-rise building, you can go for the infrastructure building, dam, and so on. You can go for the stadium, you can go for any huge structures. But how to combine all these? How to combine all these type of requirement? Okay. And also, all these requirement can be accommodated in the high performance concrete. You mix into one, become high performance concrete. All right. So this is the properties in the area of application of high performance concrete. Properties of high performance concrete, for example, increase of durability by lowering the permeability. Why? Because once you have a dense and stronger concrete, you improve the microstructure of the concrete, there will be less permeability. If you put water in it, the water will take years and years to penetrate into the concrete media. Increase of concrete density, of course, stronger, compact, stronger. Increase the compressive strength, okay? Improvement of ratio of flexural strength, compressive strength. Increase of resistance to corrosion attacks. Increase of chemical resistance. Improve abrasion resistance. Reduction of segregation and bleedings. We have discussed this in the self-compacting concrete. Bleeding is not good, and also increase resistance of alkali silica reaction by selecting a proper type of aggregates, okay, and proper size of aggregates, and improve sulfate resistance and low chloride ion penetration, diffusion, for example, and also porosity and permeability, as I mentioned earlier. So these are the properties of high performance concrete. And of course, for the applications, you can have a huge application, especially for the huge structures, for the mega structures, for example, not only for buildings, but also for the special structures, such as for the surface treatment, for the nuclear project, for the marine environment. All those are the required performance, which can be provided by the high performance concrete. All right, this is another what you call it, projects and nuclear projects in France. They are using high performance concrete with a very detailed and very fine aggregate, a very selective aggregate. Sorry. A very selective aggregates, okay, to ensure that the structure are intact. There is no loss of what you call it, gas through the wall of the concrete, for example. Because this is a nuclear station. With these two towers made of concrete, And with the high strength concrete, they can reduce the size of the tower. Right. Disadvantage. Beside the advantage of that I have already mentioned, but these are the disadvantages of high performance concrete. Number one, extended quality control beyond normal concrete. So they must, when you manufacture or when you mix this concrete, it must be properly designed to ensure all the selective material are performed very well, so that the structure can perform very well with the high quality control. When you design it, when you mix it, when you place it, when you compact it, and so on. All this must be assured and what we call extended quality control beyond. Number two, costly. Of course, looking at the material, of course, silica fume is very expensive, to be honest. Okay, if you compare with cement and other material. Okay, nowadays for the ultra high performance, you have to use a selected fine aggregates, silica sand, for example. Okay, in our case, we have to import silica sand from China. I'm not sure in Indonesia, do you have silica sand? Very fine and very high, contain highly mineral in the silica sand. And we have special constituents, as I said, water retarder. You should have all this material, water retarder, supervisor. Of course, supervisor is not an issue. Air and training agent, and so on. Carefully designed, manufactured, treated, and placed, as I mentioned earlier. Required skilled workers. Okay? And also high-scale project, uneconomic for the small-scale project. With all these selective material, highly controlled manufacturing, and with the highly controlled in supervision and so on, it is not good for the small project. It should be a huge project. For example, you're going to have a project in Kalimantan. I think it's going to be a huge project in Kalimantan, isn't it? So I'm sure they will consider this type of concrete to be used in that kind of project. Last disadvantage of this ultra high performance is not good for fire resistance. Okay, it's a very brittle material, and then there is no way of stressing under the fire. It's very high temperature, so it's not good for fire right now. Okay, probably in the near future, the new research, we can improve the high strength performance concrete in fire. Right. As a conclusion, high performance concrete becomes an important material of all structures under aggressive environment, as it enhances the visual impact and it will be able to tolerate severe conditions. And highly durable, as I mentioned earlier, and reducing size of section. Okay, size of section can be reduced if you compare, if you make it with the conventional concrete. Okay, conventional concrete, probably you need a bigger size, but with the high performance concrete, we can reduce the size of the structure member. Okay, but you will get the same strength and better performance. And of course, when you improve the structure, the microstructure of the concrete become denser, stronger, and so on, it will save the cost of maintenance. So early on, I've shown you how the concrete damage due to the very weak in terms of durability and so on. With this material, hopefully, it will save the cost of maintenance in the long term. Right. I think because of that, thank you very much indeed. So I open for Q&A. Thank you.
Right. Thank you for providing us an enlightening and interesting presentations on high performance concrete. And we are able to distinguish the difference between high performance concrete and high strength concrete, and also the disadvantage and also advantages of high performance concrete. So what I can conclude that it has that high performance concrete has become an important material of all structures, specifically under aggressive environment. So, and it can enhance the visual impact and tolerate the severe conditions. And then, even though it is also costly in terms of the material and manufacturing, so high performance concrete could save the cost of maintenance. So, Professor Badorul, we already have several questions actually. So,
Okay.
can we start right now?
Yeah. Yes, please. Yes.
Right. Yeah.
Yeah. Yeah.
Okay. So, from the first question, right. From the first question, from Bahala Kuldong, what methods for repairing concrete damaged by corrosion and deflection based on the AHTM or the other standard?
Yeah. Can I answer?
Yes, you can.
Method of repairing. Okay, there are several methods in repairing the concrete. Okay, one of the method is well, before we carry out any repair projects, any repair, we have to do the assessment. We have to carry out the assessment of the concrete first. Okay, to see how severe the damage, level of damage, what kind of damage. Okay, is that only concrete spalling? Is there only cracks? Is that because of the reinforcement corrosion and so on? If you have a cracks, you can seal it with the epoxy cracks. That is the concrete repair. If you have concrete spalling, okay, without affecting the reinforcement or tulangan, you call it tulangan, you can patch it with a certain type of material. Okay, in our case, in our research, we are using ultra high performance concrete for a repair material. You can use that material if you want. And then you can have a blanket. Okay, you can enlarge the. For example, you have you need to repair column, right? Column. You have a column problem. You can replace the reinforcement and enlarge the size of the column. You know what I mean? If I can draw something, it's very difficult. Okay, you can enlarge the size of reinforcement, the size of the column. That is the repair method. Okay.
All right. We go for the next.
Next, yeah.
Question. Right, from Dimo Adikamuru, with cement content more than 500 kilogram per in high performance concrete.
Sorry, Gina. I have suggestion. Maybe you can ask again to the what do you call the first
check.
people that
check.
have the question? Yeah.
To the check.
Confirmation. Yeah.
Okay. Question number 2. Can I just with cement content more than 500 kilogram per meter cube in high performance concrete, will it be detrimental for the contractor to apply this method? Considering it's a very expensive material. Yes, because of course, in order to attain high strength concrete, you have to add more cement. That is, you can't avoid that. And plus with the silica fume, as I said earlier, silica fume is expensive, is costly and quite expensive if you compare with the cement. Am I right? So of course, the cost will be higher. Okay.
Okay, we continue with the next question.
Okay.
Right, this one, Professor Badorul.
Yeah, this is Oka Leonardo, I'm a
From
college.
Hokkaido.
Okay, University of Sumatera. I have a question. I've heard that we can decrease corrosion of concrete with admixture, for example, calcium. I forget the names, but my question is how is our plan to improve the high performance? Well, calcium what in terms of what? Is this calcium is part of the binder or what? I'm not sure. In what form? The calcium is in what forms? In the binder forms or in liquid forms, or I'm not sure the questions. Because of course calcium, we have calcium in cement. In cement material we have calcium, isn't it? But calcium, well, I think calcium, as if like it's not good for it is. I'm not sure what the question is, but calcium to me it will be corrosion. Am I right?
Maybe calcium oxide, Prof.
Oh, calcium oxide. Okay.
Calcium oxide in the cement hydration.
I see.
Yes.
So that means increase the calcium oxide in the cement hydration. So that means the amount of calcium is more. Am I right? If you compare the composition of concrete.
The what do you call the setting time?
Yeah. That's right. I think Dr. Aswin already answered it. The setting time. Yeah, that's right. Okay.
Okay, so we go to the next questions, Prof.
Okay, sure.
Yeah, right. Okay, we go to the next questions from Tariq Al-Aziz. He asked how to make a high-performance concrete in a project area with improvised materials and tools.
Well, that's quite. It's a good question, but it's quite difficult to answer. Yeah, because well, of course, to make this concrete better, I mean the material and tool must be sufficient anyway. But then because as I said, the disadvantage of material, you should have high quality control. Okay, so meaning that all those equipment, special equipment, and so on must be there, must be sufficient anyway.
Okay, we go to the next question. How fly ash actually influence the concrete performance, Prof?
Okay. Fly ash is a pozzolanic material. Okay, fly ash is a pozzolanic material, meaning that you need water to make it react to make it react to the cement. But in most cases, the fly ash evolves in the second phase of hydration. Once you have C2S, C3S, C3A, C4AF reactions, then the calcium hydroxide, okay, react with the fly ash in the second phase of reaction. All right. That's why the amount of fly ash should not more than 20%. If you have more than 20%, they will be overreacting, and it doesn't work, and it become a filler. It's not a filler. Okay. So because during the hydration process, there are two products. One is hydrated product, CSH, calcium silicate hydrate, and the other one is unhydrated product. Unhydrated, which is produk yang tidak terhidrasi ataupun unhydrated, hydrated and unhydrated. Okay, that's why we have to limit the amount of fly ash in the concrete. So the calcium silicate might not be enough. The first phase of hydration, which is calcium hydroxide, evolve in the second hydration when you have fly ash might not be enough. If you have more fly ash, you know what I mean? Can you get me? Dr. Gina, can you?
Yes.
Okay, all right.
Okay. So yeah, right. On to
Permisi
the next.
bentar, Kak.
Yeah.
Yeah.
Okay.
So,
Okay.
is it not possible to use high volume fly ash to make high performance concrete?
Is it possible to what, Rido?
To use high volume fly ash to make high performance concrete? Because you said that we must
Have a limitation.
Limit, yes.
Yeah. Because if you put more, there will be, well, people said it's good to put more, isn't it? But that one is fly ash. It's not silica fume. Even silica fume also only 10%, 10 to 15%, something like that, not more than that. Okay, so that means, but the cement must be there. Cement must be there. Okay, that is the core, what you call it. Even though some nowadays people try to eliminate cement from concrete, but it's not good as compared to the cement. So the cement, the amount of cement must be remain, and then all this. But then the silica fume, of course, involved in the first stage. This is very active material.
Right. Okay. For Rido, is that clear, or you have any other question?
No, thank you. No.
Okay.
Saya minum dulu ya.
Yeah, it's okay, bro.
Like,
Take your time.
saya juga minum.
Lots of questions as well in here. Actually, I guess
I miss the coffee, Sada coffee.
Very nice.
All right. So, is there any question anymore?
Yes. We still have plenty of questions that I will share to you. Right. Wait. Okay. So Rido still want to talk?
Yeah, sure. Please.
I have one question about superplasticizer.
Yeah.
We all know that there's so many superplasticizer.
Yeah. Products.
And I want to ask you about how many that your recommendation for dosage or percentage that we can use the superplasticizer, and what the kind of the superplasticizer to make high performance concrete.
Okay. Redor, to be honest with you, there are a lot of superplasticizer producer in Indonesia and also in Malaysia. I think in Malaysia we are using Sika. In Indonesia also Sika, I'm sure. Yeah. Sika, isn't it? Sika. Yes. And also you can have other products as well. But the most product that I'm using now is Sika. Okay. Sika 2044, Sika, a few type of Sika. But when you're using this superplasticizer, I cannot give you the dose because it's different. Okay, it's different. You have to make a trial mix. You have to carry out the trial mix to ensure how much superplasticizer you need to put in. Okay, trial mix. You know trial mix. Uji coba, isn't it? Uji coba, ya.
Yes.
Yeah.
Ya. Perlu dilakukan uji coba ini untuk menentukan sebanyak manakah amount ataupun percentage yang diperlukan dengan workability yang diperlukan. Kalau flow concrete itu yang span table flow table itu kan, flow table itu, ujian flow table itu boleh menentukan, ujian ring itu boleh menentukan sejauh mana workability yang diperlukan. Okay. Jadi kena lakukan uji coba untuk menentukan percentage of superpressure to be used. And it can be a lot of different type of superpressure. Okay? Okay, Rido?
Thank you.
Okay, Rido? Right. Okay. So from the attendees here, do you want to ask Professor Badorul orally, or should we go for the next questions that I have gathered earlier? Anyone wants to raise a hand by clicking the raise hand button? No? If not, I will continue with the my sharing screen. Wait, yes, this one. From the lecturer from Polytechnic Negeri Medan.
I want to ask this side. This is my name is Erdi. I'm lecturer from Polytechnic Negeri Medan. I want to ask, beside the high durability in high performance concrete, how about the brittleness issue? Okay, especially for the high-rise building. What kind of material can we add to solve the brittleness issue of high performance? All right. Okay, you know, concrete is a very brittle material. Okay, the higher the strength, the brittle it can be. I mean, that is the what you call it. That is the nature of concrete. But you can improve you need to improve the strength, capacity, or the tensile strength of the concrete in order to withstand in the seismic zone, as mentioned by Ernie from Polytechnic Medan. Normally, you have to use fibers. That is number one. Fibers can be anything. It can be artificial fibers. It can be steel fibers. It can be, there are so many fibers. Number two, we found that combination of fibers and rubber may increase the strength of the concrete to withstand the earthquake. Because rubber is a very soft material. I mean, we are using rubber waste. Okay, so the rubber can absorb the impact load. You see, so we increase the toughness and the impact load of the concrete. And at the same time, if you refer to one of my papers in fiber rubberized concrete, okay, we can improve the toughness and the impact load due to the impact, not for seismic. For seismic, there are different issues because you have different type of I never done that. But for the impact load, yes. But I believe for seismic load, it can be withstand with the rubberized concrete, rubberized with fibers. In Japan, they have done it, but they I mean, it's quite difficult to share with them sometimes in their findings anyway. But then we try our best to share. Okay.
Okay, Prof, we continue to the next one from Tani Frisda.
Tani Frisda, do you have any high performance concrete or small projects? Well, how small the project is? Is it a bungalow project? Is it I don't know how small the project? What do you mean a small project? What I'm talking is a huge project like dam project, like a power station, nuclear power station, like water tank. I mean, huge water tank, sewage project, sewage plant, and so on. That's what I'm saying. A huge project. But a small project, how small the project is?
Maybe for housing, for
Housing.
housing, yeah.
Oh well, if you have a housing estate, huge housing estate, that's fine. That's fine. What I'm saying is that if you have a small bungalow, then it's not worth it. With the high strength concrete also will be enough. Because bungalow house, normally we have only the concrete, only the main structure, isn't it? The rest is brick, right? All right. Only the main structures. The rest is brick.
Right. Okay, we continue to the next one. From Taufik.
Taufik, yes. Can we use HPC for repairing or damaged hull cap? Yes, yes, yes. Well, HPC, high performance concrete. Well, I think Mr. Taufik, you can discuss with Nur Samsi regarding the repair material. I think she should know. Because you can use it, but then with the piling, is it underwater or above water? Can I see again the question?
Oh, okay, yes, why not?
Yeah. Can we use high performance concrete for repairing damaged pile caps on jetty structure? This is awal underwater. Without replace the existing damage. Oh no, you need to replace. You need to take out, or you need to have a good a new, what you call it, because you have a repair material and a damaged material. So one of the most important issue is bonding. You cannot patch the repair material to the damaged concrete. You need to take off all the damaged concrete so that the bonding between the existing and the new concrete will be intact. Otherwise, it's not good. Okay? You have to take out all the damaged concrete out first. Then replace with the new concrete. If not, it doesn't make any sense because of the bonding. And also, of course, the damaged concrete is still there, you see. So the existing concrete has to be repaired. So we will get a good bonding between the new concrete, which is for repair material, and the existing concrete. Itu ataupun beton yang sedia ada itu.
Right, should we move on to the next questions, Prof?
Okay.
There are a lot of questions. I mean.
Oh really? So until when? Until 3:30.
Until 10 minutes more. Yeah, yeah.
Okay, okay.
Okay, yeah. So
Aisha, how to make a concrete that can use in all type of construction, like marine building and high level building, striper, high level building, tall building, one type of concrete. Well, well, there are different grade of concretes in one project, I would say. Okay, for the infrastructure around, which is not involved in the supporting the structures, probably the grade is lower, 40 or 30 or 25 or 30. Okay, for the huge structures, yes, you can have high performance concrete, the grade 70, 50, 60, and so on. Okay, but for the surrounding structures, you don't need high strength, high performance concrete.
Okay.
Right. Because to make it all for high performance, the cost will be higher.
Okay, so we move on. Is there any from audience that would like to ask by clicking the raise hand button? So you could ask orally to Professor Badorul?
Yes.
You can ask orally, actually.
Oh, I see.
No, I mean,
can I ask questions? We have, Ari, yeah? Thanks for sharing, Prof. Is there any measured experiment results in using waste to get HPC waste such as brick waste? Not at this moment, because the brick waste from the bricks is basically to replace the aggregates. Waste from bricks, basically you have to crush it and prepare it for aggregate. In fact, the amount of bricks, waste from the bricks, it is not 100%. It's not 100% unless you have a very good bricks. Fired clay bricks, for example. Okay, so that is a good bricks. Fired clay bricks are good bricks, and it's good to use it as aggregates. Okay, but the percentage, it can be 40%, it can be 50%, or it can be 100%, but normally less than 100%. Yes, but for the high performance, so far, I don't see it, because you know, the high performance concrete needs a very strong aggregates, as I mentioned earlier. In fact, the size also reduced. Normally we are using 20, isn't it, 20 millimeter, but the size of the high performance is between 10 to between 9 to 10 to 12 to 14 and so on. But I'm not sure in high performance. But it can you can do research if you want to attain high performance concrete using waste from the bricks. But the bricks is vary. You can have fire clear bricks. You can have calcium silicate bricks. You can have stone blocks, or you can have a concrete block, for example. There are so many types of waste from the bricks and block.
Right. So we go to the next questions from the Ariston. Is there a formula for planning a rigid pavement in a city with a
formula of
causeway?
planning a rigid pavement in the city with causeway. It is a formula. It is a formula, because a rigid pavement is for the this is actually related to the highway material. You see, some of the highways, they have a concrete what you call it, concrete pavement. Okay, you have seen concrete pavement? Yes, there is a concrete pavement. Okay, with the high performance. In one of the stretch in the North-South Highway, we have one portion made of concrete. But there is a lot of problem anyway, but then they still serve until now, especially quite noisy. Yeah, you can see your tires and so on. It's not comfortable to the drivers. But then at one point, normally at the what you call it, petrol station. Okay, petrol station. Normally they make the pavement with concrete. There is a formula, of course.
Right. So we move on. There is someone, Harrison. Mr. Harrison, do you want to ask your questions orally?
Mr.
Harrison Ingot Hasudungan, do you want to ask questions orally?
Here, from yeah.
No. If not, that.
From the chat here, I can see a few questions.
Yes, from this, I already gathered the questions from the chat box.
Oh, I see. Yes. Muhammad Arif, Assalamualaikum. Salam. I want to ask what treatment can be applied to create high performance concrete that is more environmentally friendly? Well, the best treatment is basically water ponding. Okay, but then of course it depends on the orientation and location of the structures, isn't it? Sometimes you can have a pour water ponding for how many days? For 7 days, for 10 days, and so on. But with the high performance concretes, you need to have what you call it, material to accelerate the hydration process or to cure it in proper manner. Okay, So in terms of curing, there is a lot of issues in curing. For example, if you are not properly cured, you might, the hydration might not be what you call it, might not be proper. So end up with the end up with the porous concrete and so on. Okay, so there is a method of curing. Okay, sometimes you need to spray with the chemical to cure it, or to insolate the structures. Am I right? Am I answering the question? Can I show it? Can I see the question again?
Oh, yes.
Okay. Okay.
Yes, this one.
All right. All right. Okay. Treatment. Yeah. More environmentally friendly. Well, this is for a very difficult question. More environmentally friendly. Water is more environmentally friendly. If we compare with the other material, if we compare with the other methods. Water ponding, for example, or you can use blanket, for example. Okay. Right.
Okay. Right. So should we move to the last questions, because it's almost 3:30 right now? 4:30.
I'm sorry. I cannot answer all the questions. A lot of questions.
Yeah, lots of questions. Yeah, because your presentation is very interesting. This one from Dedi Shaputra, Prof.
What kind, Dedi Shaputra? What kind of effective method to optimize high performance concrete in the area with full of water spring, the dam, or lower elevation from surface? Okay. In this case, I've seen in the projects nearby. They are using, you know, they're using high performance concretes. But then when they pour the concrete, they pour with the bentonite. You see the bentonite in the surrounding, what you call it, in the cast irons. So once they pour it, they pour with the concrete. Okay, so that means it will not interrupt during the hydration process. Okay, what should I say? During the construction of piers, you know, piers, columns, piers for the bridge. Okay, piers. They excavate the soil coming up, but when the soil coming up, they put bentonite in it, and there are a lot of chemical whatever, and then with that, after that they pour the concrete in it, so they will not be affected with the surrounding area in the sea. Okay.
Okay. So do you still want to answer, or at the kind of a closing statement from Professor Badorul?
Say again.
Do you want to answer one last question?
Yeah, please. Yes.
Yeah, okay. So the question is coming from Kusuma Permadi, whether the type of cement, cement affects the ultra high performance concrete.
Yeah. You have type 1, type 2, type 3, isn't it? Different type of cement. And cement between the cement also different between the manufacturer. Okay, I have experienced testing cement from different manufacturers. I think Dr. Aswin, he knew about it. We have few cement manufacturer here, not many, from Perak Hanjung, from Tasik Cement, for example. Yes, the quality of cement are different, I would say to you.
Yes.
Of course, if we look into the what you call it, the chemical composition, they are almost the same. They are almost the same, but probably they are using different clinker. Okay, so you have to test with different type of cement. But of course, there is a limit. There is a code of practice. They have a range of material and so on. But then sometimes the quality of cement from different manufacturer has different quality, I would say. That's why we need to have uji coba ataupun testing, trial mix to ensure you will attain a required strength and required performance as you want.
Right. I guess this is the end of our Q&A sessions. Thank you to Professor Badorul Hisham Abu Bakar from University of Malaysia for providing us the very interesting and engaging discussion.
Thank you very much.
I'd like, for Dr. Insyir Ahmad Prawira Mulia Tarigan, do you still want to have some closing statement? No? Okay, so if not, then once again, on behalf of the organizing committee, Postgraduate Program Department of Civil Engineering of Universitas Sumatera Utara, I would like to thank, oh no, okay, so he's still there? Right, okay, on to you.
I want to express some gratitude to Prof. Dr. Badorul Hisham.
Thank you very much.
Always inspiring and always energizing. Yes, I've been listening to your presentation about high performance concrete. So, but forget something, but then remember something. Yes,
all right.
But we all miss you, and we hope that.
Thank you, Rash. Thank you very much.
What you call this pandemic will be over soon, and you
inshallah.
can visit us again at USU.
Sure, inshallah.
And on behalf of the postgraduate program of civil engineering of USU, we would like to express our gratitude to Prof. Badorul Hisham.
Again, thank you.
Given presentation on high performance concrete in this international webinar. Your sharing of knowledge and experience is indeed beneficial to all audience in this webinar. And this webinar is one of our effort in the program of internationalization to become world-class university. We believe this webinar will further strengthen our collaboration with School of Civil Engineering of University Science Malaysia
inshallah,
in terms of guest lecture, joint research, joint students profession, joint others, and etc. Thanks again, Prof. Badorul Hisham, for your role in this endeavor. Thanks also to Dr. Gina, who has moderated the webinar, and special thanks to Prof. Johannes and Dr. Aswin, who encouraged us to have this webinar with Prof. Badorul. And last but not least, thank you very much to all the participants. I hope you gain more knowledge on high performance concrete, and we hope to see you again in the next international webinar. Thanks. Thank you very much.
Right. Thank you so much. Yeah, thank you so much, Dr. Prawira, for the closing statement. So once again, on behalf of the organizing committee, we would like to say thank you to Professor Badorul Hisham and to all the participants, to our excellencies, distinguished guests, for attending this webinar from start to finish. So we hope we can enhance our knowledge on the concrete technology, especially about the high performance concrete. And we really hope that we could meet in another opportunity and in the next webinar sessions. And I hope that Professor Badorul could join us again in the next webinar. So have a good afternoon and stay safe and stay healthy during this.
Thank you very much indeed. Okay, thank you. Yeah. Thank you, Prof. Johannes, Dr. Ahmad Prawira, Dr. Aswin, Dr. Daniel. Is he around?
Ya, kita udah ingin makan musangking lagi di Penang, Prof. Badorul. Itu hari kita sempat makan durian.
Oh ya, kami. Okay, Dr. Medis and all of my colleagues in USU. Thank you very much indeed. Thank you.
Okay,
Eh,
thank you.
Inshallah.
Inshallah.
Okay, terima kasih. Terima kasih.
See you again.
Yeah, see you, Dr. Asmi.
Badorul.
See you.
Yeah.
Thank
One
you,
more thing,
sir.
we are wondering about Nur Shamsi to finish his study next year. What is there any possibility that we can finish study?
Yeah. I think I have to discuss with her and also with Prof. Johannes how to plan and how to go about it because of this pandemic. And I still keep her specimen in the laboratory, and she will come after this pandemic slow down and then carry out. I will keep it, and inshallah I will try my best to help her.
Thank you, Prof. Badorul.
Thank you very much. Thank you.
Thank you.
Okay. Thank you. Terima kasih. Assalamualaikum.
Terima kasih.
See you.
See you. Have a good
Terima
afternoon,
kasih
everyone.
banyak untuk seluruh
Assalamualaikum
peserta
warahmatullahi
yang
wabarakatuh.
hadir.
Thank you, Prof.
Oke, boleh